Okay. Perfect. So welcome to my little lecture about how to set up C-Lightning, your very first, your own Lightning node. Since I've thought setting up just a Lightning node, which is something that I do like twice every minute, is a bit boring, I thought I might actually do it on a Raspberry Pi, so that if you want to, you can actually get your own Raspberry Pi for like 30 bucks and build your own little Lightning home hub, and then connect through from a mobile phone to this Lightning node and have your very own Lightning node in your pocket as well. So the structure that I'm going to use here is basically I have this Raspberry Pi attached over an Ethernet cable to my notebook. The notebook itself is running Bitcoin-D, so there is no Bitcoin-D running on the Raspberry Pi. The Raspberry Pi is pretty much pristine. I have not installed anything besides two dependencies and the Bitcoin CLI, which I'll need later. And the laptop is actually my gateway to both the Lightning network and the Bitcoin network. So that's basically the structure we are going to use once we're set up. And I just want to give you an overview of what this will eventually look like. So the first step that is actually needed is to set up Bitcoin-D and Bitcoin CLI. And since Alekos did a very excellent job at explaining how to do this, I thought I might actually skip this. And it also takes loads of times to synchronize a Bitcoin node. So you probably I did that ahead of time, so you guys wouldn't have to wait 19 hours before proceeding the thing. So what I did is basically I have this this Raspberry Pi node to which I will now connect. And if you are wondering what these magic numbers are, it's basically just tunneling a port on the Raspberry Pi onto my notebook so that it looks from the Raspberry Pi as if Bitcoin-D were running locally. Eventually, we will remove the need to have a fully synced Bitcoin-D in the first place. And you are not working again. Why are you not working? Come on. There it is. For some reason, I keep losing the IP address. So now we're on the Raspberry Pi, and I just want to show you that Bitcoin CLI is able to talk to Bitcoin-D. This is sort of the preparatory work that we've done so far. The terminal, yes, sure. Is that better? Bitcoin CLI. We're running on testnet because, well, I don't have any mainnet funds here at the moment, so that's probably the only option we have. And what this does, it shows that we can talk from the Raspberry Pi using Bitcoin CLI with the Bitcoin-D on my notebook. Passwords are set correctly, and we can interact with it. So the first thing that we need to do is basically we need to download and install the C-Lightning implementation and install its dependencies. I already went ahead and installed libsodium, which is the only runtime dependency we need for C-Lightning. So we can just proceed and install the Debian package itself. So like Alekos, I'm using wget to fetch this package. It's rather small. It's less than 600 kilobytes in size. And this is the entire package that you need to install on this Raspberry Pi. Now, once if you run this on a laptop or on a desktop machine, it's very likely that you will you will be able to download this from the software installation menu of your operating system. But because the Raspberry Pi has a bit of a weird architecture, I had to compile this and make it available over the network, and we have to install it manually. But if you're running Ubuntu, for example, you can add our repository and just do an apt-get install Lightning D, for example, and it will just pull in all dependencies and it will deploy and it will be ready. So what we do now is we install this package that we just downloaded using dpackage-i and the package name, and of course we need to use root to do that, and it will eventually just unpack everything. And once that's done, we have installed Lightning. That's the entire presentation. Thank you very much for listening. No, we'll actually go ahead and actually start using it as well. So, so now that we have installed the package, we can actually start running Lightning D by just calling Lightning D with a couple of options. And in this case, I'm actually, let me just go back here. So what I'm doing is I'm starting Lightning D with a higher, with the debug logs, because I feel more comfortable seeing stuff happen on the screen rather than seeing a blinking prompt that does nothing for a long time and you don't know what's happening. So I'm actually turning on debug logging, and I'm also setting the network to be testnet. This is the default for C Lightning currently. But it's probably a good idea to just say which network you are running on. Now, the wallet, so when starting this, it will create a wallet for Lightning. It will initialize a database. It will create a new secret key. It will all happen automatically. And what you'll end up with is that eventually, I'm not used to seeing it this big. So what you'll see eventually is that the server started with this public key. So this is a public key that uniquely identifies our node inside of the network. This is automatically generated, and a code name that we've stolen from the NSA handbook. This is also automatically generated from your key. So funnily enough, it decided that we are Weird Genesis, and we will call this node Weird Genesis from now on. It also has a color, by the way, so if you ever look this node up on a Lightning Explorer, you will see this node colored in this fashion. We thought that was a nice touch for people to actually get to know their node by dressing them up in different colors. So what we also notice is that as soon as the node starts synchronizing with the Bitcoin testnet. And we'll see that it does not download all the blocks from block height 0, but it will actually go back only 14 blocks, and it will walk through those blocks. If we were to stop this node and restart it, it would basically continue scanning from the place where we last stopped it. Okay, and we get some scary messages that should not preoccupy in any way. So I'll leave that node running up there, and I'll now open I'll connect on the lower part of the screen to the Raspberry Pi again, and now we'll see how do we interact with this node. Now this node is running, and we want to use it in some fashion, and what we see is that we have in our home directory we have created. Apparently my aliases aren't working. We have created this directory which has a lot of fun stuff in it, but most importantly, it has a file called HSM secret. This is the key that we generated for you. This is basically the basis of all of your funds, so don't lose that one. We have a database that manages the state of the node itself, and we have this file Lightning RPC. So what this is basically our way to interact with this node. Whenever we read and write to this file, the Lightning node will reply to it. By default, we do not expose the Lightning node over the network, so there is no way for you to accidentally expose this to the rest of the world. You need to have access to this file, otherwise you can't interact with it. Now, how do we interact with it? We have a tool called Lightning CLI that will do just that. So Lightning CLI help will give you a lot of interesting things you can run on your node, and most importantly, let's just run Lightning CLI get info, and it will tell you basically all of the information that you should know about your node. It tells you where you can connect to it, what its name is, what its color is, and its ID, to which network it's connected, whether it's in sync with the Bitcoin blockchain, and really important things like how many fees did I collect. Okay. So what do we do to open a channel? In order to actually use our Lightning node, we need to open a channel to the rest of the network so that we can send payments through that channel, right? So before we can actually open a channel, we need to give some Bitcoins to this node in the first place so that it can open channels. So what we do is we generate a new address from Lightning CLI. And this address will basically will result in all funds sent to this address being. Do I need to scroll up? Okay. This address, basically, all the bitcoins that we send to this address will be added to the internal wallet of Lightning and will be available to fund channels or to send on-chain transactions from there. So what we do is basically, I just use Bitcoin CLI. Let me just open this one again. Testnet, send to address, this one, which is the address that we just generated, and we'll just send some funds over to it, right? So this is how we send a transaction using the Bitcoin CLI tool to the Lightning node itself. So this is where we take a 10-minute break because, well, this actually needs to confirm on the blockchain. And going over to the Blockstream block explorer, we see that it's unconfirmed, but it's out there, and we just have to wait. So now it's my turn to sit here and look at your face. No, just kidding. I've actually prepared the same demo on my laptop a few hours ago, and this is a node that I've been running for a few hours now. And what I can do is basically, this is the node called Orange Monkey, and this has some connections open. So if we want to look at this, we have list peers, which tells us that we are connected to a node 03933 whatever, and it's connected, and we are connected to another node 027 whatever, and we're also connected. So this is a node that has two channels open, and if we want to look at it, it also has some funds here. So it has two channels open, one for 16 million satoshis and the other one for 7.1 million satoshis. And because I wanted to show you also what you can actually do with this, I thought let's maybe buy a coffee and come back to this to how we create a channel once we've done this. So what I have here is a demo shop by our good friends from Assange. This is our friendly neighbor company that is helping us implement and specify the Lightning network, and they've created this demo, which basically allows you to add a few coffees to your shopping cart, then proceed to checkout. And what you can see here is that we have a QR code that if you have a mobile phone that you want to use, you can basically scan, or if you have, or if not, there's this textual representation of the same invoice that we can use to pay here. So what I'm going to do here is basically I'm going to call Lightning CLI pay, and then I'm just copying in this invoice, and if everything goes well, I should be able to press enter here and it should turn green on the left side. And that basically means that the payment went through. So enter, enter, and I did not have my sacrifice for the demo gods. That's fun. Okay, so something went wrong there. I'll just restart the node and where does it say success? Oh no, that's wrong. So let me just check that that we're actually connected. List peers, peers, state, connected. So both nodes are connected, and if everything goes well, I should be able to pay this. Oh yes. So I was worried for a second, but I have a good excuse for it, that it didn't work. So apparently what happened is that it had the connection open and I shut down my laptop and it just got stuck there. Okay. So I'm afraid that's almost it, because unless the transaction that... Oh, we actually have some money here. That's good. So we can actually go ahead and open a channel now. So let's go back to our cheat sheet, and what we do is we connect to a node on the network, and what will happen is that after connecting with this node, we will start synchronizing the view of the network between these nodes. So I basically will learn about which other nodes exist in the network and where they are located and where are channels. This is important for us to later go ahead and do payments, because we need to find a way from us over a number of channels, over some hops, to the destination so that we can perform our payments. And if I now do a list nodes, I should... No, it's not synchronizing. Oh well. But what we can do now that we are connected, we can actually say, hey, I'd like to fund a new channel, and that's exactly what we are going to do here. Is what we say, hey, I'm connected to this peer. Please now initiate negotiation with this peer and start a channel on top of it. And what we have here is both nodes negotiated between themselves about parameters that they want to set up, how much time to wait in case one of us goes down until the other one reacts, and so on and so forth. And eventually what is the result of this is they will both send a transaction into the Bitcoin network, and this transaction is basically sending from my money into a multi-sig account that we now share between the two endpoints. So this is what I usually like to compare it to putting money on the table, so that none of us can run away with the money, right? And this is the second hiccup. We now have to wait for this transaction to confirm before it... am I picking the right one? No. Before we can actually use this channel. So that's the reason why I created the second setup in the first place. But once this confirms, we now have an active channel. We now have a node set up with an active channel to the rest of the network, and we can start paying invoices as we see them on the net on the web. And if this was too much of a terminal play, which is what I'm used to, then Nadav is going to give the next presentation, which gives you a nice interface that does not require you to remember all of these commands. But I thought we'd start with this low-level stuff first, and then upgrade to the nice UX version. So I don't think this will confirm in time, especially because testnet is really unpredictable. But we just went through and installed Lightning D. We started a node. We set up a channel. We synchronized the network gossip, and we now have a fully functional node. And if you want to do this yourself, I will gladly show you on Sunday, and I will also publish my notes after embellishing them a bit and adding a bit more details in here, and hopefully you will be able to set up your Raspberry Pi home hub at home so that you can have your own node at home that you can use for your own needs. I'm available for a few questions if I have time.
I'm thinking, what I'm thinking is, I think we're going to go through all for 4 more lightning demos, and then if we have a few minutes after, all 5 of you can come on stage, and maybe somebody can ask if we have a few time for questions all together.
Excellent.
So we'll do. I think that way is better.
Thank you. Nodal.
Isn't it Nadav?
There. Okay. Do you need time to set up, or you can go straight ahead? 2 minutes. So wait a second, Christian. If there is a question, maybe Christian can answer just one question. In the meantime, Michael can set up there. Okay.
Not all at once, please.
Yes.
Yeah, well, it's kind of cool when the camera should be working. Yeah. So, okay.
So this is the screen.
Strategy with C Lightning to separate and isolate into multiple different processes. Maybe this is slightly off topic from what you were describing, but is that a thing, and is that already in place?
Yes, so the overall architecture of C Lightning is such that we have very specialized modules that run in parallel. Actually, what we just did is spin up a C Lightning node that behind the scenes was running 5 to 6 different processes. And you don't see any of this, but the architecture would allow you to customize each individual piece if you had the need.
What are the 5? I'm really curious.
So the 5 are the main daemon, which is Lightning D. Then we have the gossip daemon, which takes care of managing your view of the network and searching paths between 2 nodes in the network. Then we have opening D, which is used to open a new channel. We have channel D, which is used to manage a channel, and we have connect D, which basically just takes care of accepting incoming connections. So this has both a security as well as an extensibility use case. Security, if you compromise any one of these nodes, the attacker is confined into this process, cannot access whatever private keys, for example. Oh, and HSMD. Sorry, I forgot about that one. And on the other side, there's the extensibility argument, where you can actually say, I'd like to customize whatever this node does. I'd like to find different routing mechanism, or and you can just do that by replacing an individual daemon.
Cool, thanks.
Thank you very much, Christian. Oh. So.